Imagine if 90% of all silicon chips depended on sand from just one place. That's right. A single mining district in the mountains of North Carolina supplies ultrapure quartz that underpins virtually every piece of modern technology. The phone in your pocket, the servers running the internet, the chips inside your car. Trace any of them back far enough, and the trail leads to the same quiet patch of Appalachian ground. And almost nobody who depends on it has ever heard its name. The town is called Spruce Pine, population a little over 2,000. A general store, a couple of churches, train tracks running through a narrow gorge. There is nothing about it that announces it as one of the most strategically important places on the planet. And yet, if you wanted to bring the global supply of advanced chips to its knees, you wouldn't target a factory in Taiwan first. You'd start here. To understand why, you have to follow the strange journey that turns ordinary-looking rock into the brain of a computer. It begins not with the silicon itself, but with the container it's purified inside. Making a chip requires melting silicon at temperatures above 1400 degrees Celsius, and that molten silicon has to sit inside something. That something is a crucible, and the crucible is made of quartz. Here is the catch that almost nobody outside the industry understands. If even a few atoms of impurity leach out of that crucible wall into the molten silicon, the entire batch is ruined. The chips made from contaminated silicon simply don't work. So the quartz lining the crucible has to be almost unimaginably pure. We are talking about parts per million of unwanted elements, and in the most demanding cases, parts per billion. Most quartz on Earth cannot come close to that standard. Sand from a beach, gravel from a riverbed, even quartz mined for glassmaking carries far too much iron, aluminum, titanium, and other trace metals baked into its structure. You can refine it, but the deeper impurities are locked inside the crystal lattice itself. They don't wash out. For the highest grades, you essentially need rock that was born clean, and almost nowhere on the planet produces it. That is what makes spruce pine extraordinary. Around 380 million years ago, a slow geological collision buried this rock deep underground, where extreme heat and pressure cooked it for hundreds of thousands of years. The slow baking drove out impurities and grew enormous, exceptionally clean quartz crystals. When that ancient rock eventually rose back toward the surface, it left behind a deposit so pure that no one has found a real equal anywhere else. Once the rock is mined, it's crushed and put through a punishing refinement process. Magnetic separation pulls out iron. Chemical baths strip surface contaminants. Flotation and acid leaching remove still more. What emerges is a fine white sand, so clean it looks almost like powdered snow, sealed in bags, and shipped out quietly to a handful of customers around the world. From this point, the quartz vanishes from public view and becomes one of the most invisible inputs in modern industry. The mines themselves are run by a small number of companies operating in the same district, and the highest grades of quartz they produce are treated as closely guarded trade secrets. Exact purity figures, processing methods, even precise output numbers are rarely published. Buyers sign long-term contracts. The product flows mostly to crucible manufacturers, many of them in Asia, who shape it into the vessels that semiconductor and solar companies depend on. A few quiet operations, a few quiet buyers, and an entire industry resting on top. This is the same pattern we see again and again in the hidden machinery of technology. A material almost nobody thinks about turns out to be a single point of failure for everything built on top of it. The supply of neon gas for chip lasers is one example. Spruce pine quartz is another, but it sits even further upstream, closer to the very beginning of the process. It is the choke point behind the choke points. And that concentration is exactly what worries the people who study these systems. When a critical input comes from one geographic area, every threat to that area becomes a threat to the whole industry. A labor dispute, an environmental ruling, a corporate decision, a natural disaster. Any of them could choke off supply for a product that the world has no quick substitute for. This is not just theory. In 2008, the roof of a chemical plant in Spruce Pine collapsed, briefly disrupting operations and rattling buyers around the world. And in 2024, Hurricane Helene tore through western North Carolina, flooding the region, knocking out roads and power, and forcing the mines to halt production for weeks. For a stretch of days, one of the most important taps in the global tech supply chain was simply turned off. The industry survived because companies hold stockpiles and because the disruptions, so far, have been temporary. But the deeper vulnerability never goes away. Decades of searching have turned up deposits elsewhere, in places like Russia, Brazil, India, and China, and synthetic quartz can be manufactured too. Yet for the very highest purity grades, at the scale and cost the industry needs, the alternatives have struggled to fully match what comes out of those North Carolina mountains. Part of the reason is economics. Building a brand new ultrapure quartz supply means proving the deposit, building refining capacity, and convincing cautious manufacturers to qualify it for production, a process that can take years. When an existing source already works and already meets the spec, there is little incentive to switch until something forces the issue. So the dependence quietly deepens, year after year, even as everyone in the industry privately knows the risk exists. So the next time you hold a phone or open a laptop, it's worth remembering the path that made it possible. Long before the wafer, before the fab, before the gleaming machines worth hundreds of millions of dollars, there is a bag of white sand from a mountain town most people will never visit. The most advanced industry humanity has ever built rests, at its foundation, on ancient rock from a single corner of North Carolina. And whether that remains a quiet footnote or becomes a headline depends entirely on what happens to the ground beneath Spruce Pine.
If you found this deep dive valuable, hit the like button, drop a comment below on what tech mystery we should decode next, and subscribe to never miss an episode.